This is a quick review on the Ucore, what they call a fault locator, their model use Ct202l fault locator. This device is made over in Europe, and there was very little that I could find on the internet. I did buy this direct from the Ucore folks, and basically it's a voltage current curve tracer. Comes with about a 10-page manual. It's very small. If you're old like me, it's you're going to need your reading glasses to be able to use it. There's an interesting story we'll get to in just a little bit about the problems I've had with this. The problems were my problems, and should have known better, but there was a faulty component in the unit I was working on. So let's do a quick overview of this voltage current tracer. This is what the unit looks like. It's basically a processor board with a display on it, and it puts out various voltages which you can select in various frequencies, and it generates a curve that you can see. If we start from the over here, and it comes with this little nifty little pen type deal that takes you back to the days of a BlackBerry, but the info is simply, and it's kind of washed out, but it's all it is basically a about page that has a serial number on it. There's also a probe calibration. It comes with two probes that are terminated in BNC to the end of the unit, which is here, and it's basically a 2-channel unit. And when we select probe calibration, I'll get some of the glare off of that. It tells you to connect the probe to the A channel and short the probes together, and when you do that, touch the panel to continue. It goes through a very quick, basically 0, and the probe's out, and it probably reads the resistance and the capacitance of the probe. So once we've done that, we're good to go. Then we can go to screen calibration, and again, this just click on the crosshairs, and this will tell the unit where everything exists. You can also capture the pictures of your display whenever you have a trace, and if I had captured any, they would be located in here, and I could delete, open them, close them, and format them. So we'll close that. You can also use this as a USB drive, but that's not the primary purpose. The primary purpose for that would be for updating your software and taking any of the files that you had captured of the trace and taking them over to your main computer. And now for the heart of the matter, let's go to the tracer. So in the tracer, this is open probes, and you can print the screen. You have 4 different voltages levels that are, you see, in low, 1, 2, and 3, referring to the manual. And it says low is 5 volts, plus or minus 5 volts. Low 2 is plus or minus 5 volts as well. So I'm not quite sure why we have 2 of the lows, but and then medium is plus or minus 10 volts, and high is plus or minus 20 volts. So, and just a quick reference to the low 1 is 6.625 volts for division, and low 2 is 1.25 volts per horizontal division. So your voltage is read on your x-axis, your current is read on the y-axis. So let's look at a component. We'll throw and these are brand new capacitors. We'll throw one on here and connect it up to the into the device here. And we've got a 2 kilohertz signal applied to it, and at 5 volts. And this is what this particular cap looks at. This is a polyester film cap. Let's go over and look at a ceramic disc cap. A little bit different display. You see that basically, and let's see what happens when we change this from low. So this is changing your voltage on the x-axis, and we changed this, went to 10 volts voltage, and now went to 20. And then in the scan mode, we'll go through each one of those various voltages. If we had a second probe set up, we could compare two caps, one right on the other. This is where this unit shines. If you have a good component, you can place a good component and then place a component under question on the other channel, and you can determine if that component is good. How about electrolytic cap? This is a 30 microfarad electrolytic. And that's disconnected. Now we're going to connect it up. Let's go to, right now we're not showing any voltages. It looks just like the leads would be shorted. Change the frequency, see if that, there we go. And that's your electrolytic. My guess, and it's strictly a guess, is if we had, and over time the voltage, maybe not, since we are going plus and minus, it's putting an AC signal on there. We're probably not going to see that grow. It's not going to charge that cap up. We'll put a diode in line. This is an LED here. Okay, and you see at 0.65, looks like this is a red LED. And I don't know if the camera will pick this up, but you can actually see that it's pulsing this LED as it goes back and forth at 10 hertz. At 100 hertz, it goes solid. You can't see it. 500, 2000. If we apply more voltage there, I don't want to hit it with over. That's just a little diode. It blows. So what? We changed our x-axis. Now we're going to put 10 volts on it, and it still didn't blow it. And there's 20 volts. So, alright, that's with the actually positive and negative, will reverse the leads, and you see you have the reverse indication there. How about a power transistor? Okay, no conduction there. And out between those leads we're good. We've got some. So basically, if we take it down here, see if it's going to turn on at 5 volts. Yeah, it looks like a standard standard junction here, turning on at about a little bit more than 6 1/4 volts. So and reversing it. Okay, so if we had our second set of leads up, we could stack them on top of each other and see what's going on. So we were able to change the frequency, change the voltage. 1 and 2 changes the scale. We can have it scan, which will run it at all different voltages. We could actually print this out, which is going to print it to a file. And then if we go to page 2, when you're running 2 of them, you can take and move the traces up and down on here. And then on this page, you can also change the frequency between 1K and 10K. So that's pretty much the unit. It does exactly what it says. It's about a $300 unit. Might be a little bit pricey, but now let me tell you about the service experience I had with these guys. And this thing has been very helpful as far as oh, one other thing, forgot to do this one. Let's go back. It's been helpful chasing down stuff that we do, and you work with, shall I say, we work with a cold unit without the power applied to it. Here's just a plain old resistor. So that's a resistor. Let me see if I've got a different value here on the bench, or put my hands on. Oh. Here's a 47. Looks like 47K. And you can see that that is quite a bit of difference between this guy, which was in the megs, and it just happened to be one that was sitting here on the bench, and if it was sitting here, it was probably not reading right. It's probably really close to being open. Let's see what else we got over here on the workbench we can grab and look at. Diode. Oop. Diode one direction, and we'll switch it over. That's a short, open, and now the diode in the other direction. Another resistor. This is a metal film, and I can't read the color code. And you see the slant's a little bit different on the resistor. What you should note is that the resistor is conducting on the negative as well as the positive voltage levels, where when we went to a semiconductor, it was only conducting in one way, so nothing going on here, and then all of a sudden it hits, in this case, let's go down here, it hits 6 point something volts, or 0.6 volts, and there we go. Alright, now for the story of the service with this guy. I was using this thing and was working on a on an old power supply that was plugged in and was not on an isolation transformer, which is probably mistake number one. I know better. But I wasn't planning on touching anything that would have been hot. It was plugged into my Variac. The switch was turned off on the unit, and I was not measuring anything. I simply picked the probes up and was moving them over, and in the process I hit a ground. Also had this thing powered by USB, which I forgot to tell you about. This can be powered right off your computer, which I don't suggest because that was my problem. I have since got a little battery box, USB battery box, and what happened when one of these wires hit ground, that ground was hot. Even though it was plugged in, it was not isolated, and it went through the unit, and I'll show you what happened. It went through that channel that was connected. It's turned around where you can see it. Took the trace off, burned the trace off of there, and in the process ate up a number of components in there. So these guys are in Europe. I don't know if it says where they're at in Europe, but anyway. So their time zone's terribly different than ours, and all this was done via email. So I would send them an email in the afternoon, and the next morning I would get a response. So I sent them an email, told them what I had done, admitted to my mistake. It was not their problem, and lo and behold, they said, "Oh, there's some little protection diodes here. Go get those and replace those. Q1. That's the first thing it was." So and you can see the sloppy solder job. Theirs is not near. Theirs is very nice. So I went and replaced those. Then there's a couple little solid state devices here. I replaced those, and then still didn't work. So they sent back some troubleshooting clues. Check the voltages here, here, and here. I did. So they said, all right, replace the capacitors, and they gave me the numbers, this one, this one, this one. Flip the board over. This is where the power comes in. Replace this capacitor, this capacitor, this capacitor, all those capacitors. Replaced all of those. Did not fix it. Then there was some teeny weeny resistors right here. Replaced that resistor, still no good. Replaced this guy right here, still no good. So kept checking. They said, okay. Finally they got down. Well, this U15 is some type of voltage regulator, I believe is what they said. And I was not getting any. I was not getting my 5 volts into to where it should be. And they said, well, it's probably this voltage regulator. I don't know if you can see this, and probably if I pulled out the microscope, you probably could. But they finally got down, and this is after about 2 weeks of going back and forth. They says, oh, replace U15. So, and it may have been more than 2 weeks, because when I went to, I did not have, obviously didn't have all these parts in stock. Had to go order the parts, wait 3 or 4 days, they'd show up, I'd put them in, then I'd send them a text, and back and forth. So this guy here is beyond my soldering capabilities. I don't know if I can get that where you can see it, but there's about 10 pins, about 5 or 6 on either side of this little guy right here. So at that point I said, guys, that's it. I'm done. Sell me another board. Let me know what it cost. And the guy says, okay, here for you is a deal, and I don't remember, it was less than about $100. This is the heart of the whole unit. So the display that we had over here, I believe they found that as a standard off-the-shelf part somewhere, either as a one of the Adrenos or one of the standard microprocessor displays. It's my guess. I don't know that for a fact. Just guessing. So this is the old board. Basically, my fault. I touched it to a ground that was hot because of a bad component that had not totally discharged, and when it did, it discharged through the power port, which is this port here, to the computer. I was fortunate that the computer apparently had decent enough protection that it did not harm the computer. Since then, when I power this thing on, I use a USB power battery that you can buy in Walmart, or who knows where else, but and it powers it for quite a while. I can get a couple, 3 hours out of it. And normally this is something that I only use for a few minutes. One last thing, I don't know why they have this. They have a reset button and a boot button. Every time you turn it off, it turns off, and then when you unplug it, there's no turning it off. When you plug it up, it turns on. So, well, that's it, guys. Not a bad little device. Maybe a little bit pricey, but seems to be well made. The people that selling it and built it, I believe, are one and the same. I don't know where all you can find it. I know you can find it at their if you search for Ucore Electronics, you can find it there. They do make some other devices. I was just looking for something that would be somewhat similar to the Huntron tracer, which I don't have. I have a leader. I don't remember the model number, but transistor curve tracer, and that requires a scope, and it's a big box, and it's bulky, and it takes lots of room. But they have a little short description in here to tell you what you're looking at. A capacitor makes an oval, a resistor is a slant, short circuits straight up and down, open circuit is a horizontal line. This would be a diode. This is an emitter junction. This is a zener, and I think this is a base emitter junction that's degraded. So they'll tell you that it will test resistors, capacitors, coils, general purpose diodes, zeners, varistors, virtually any type of transistor. You'll do SCR, triacs, relays. You can look at those, see if they're open and closed. LEDs, phototransistors. You can even check integrated circuits if you've got two alike. And I worked with the LM723 was what I was working with on this when I blew this thing, which was on a power supply. Turns out that was not that was only one of the many problems on the power supply. Was the 723. It had been, I believe, grossly overloaded. So that's it, guys. The Ucore, is it Ucore? Yes, Ucore Electronics Fault Locator. I hope that was helpful to somebody, especially if you were looking at buying one of these things. I've got it. I use it, not daily. I would put it right up there with some of the extra equipment I've got that you could probably do without, but it makes life a little bit easier. And I'm sure there's other ways that you can skin this cat without spending that money. And you can also spend $1,000 or better and get one of the Huntrons, which maybe one of these days, but who knows. Have a great day, and